Good afternoon, everyone. Last class we finished with the topic molecular formula and empirical formula. There we studied how to predict the molecular formula of a compound and how to predict the empirical formula of a compound. So students, if it is simply asked in the question to find out the formula of a compound, then you will calculate always the molecular formula of a compound and you will not go for the empirical formula method. When the question it is specifically asked to find out the empirical formula of a compound, then only you will use the method empirical formula method to find out the formula of a compound. Okay, so there also we studied how molecular formula is preferred over empirical formula, and to find out the formula of a compound, why we use only the molecular formula method, because it gives the exact number of atom present in the molecule of a compound. Also it gives the exact type of the atoms as well as the arrangement of atoms in the molecule. So molecular formula means the formula of a molecule of a compound. Okay, the next topic is molecular mass. It is just like what we have studied in our previous classes about the atomic mass. Atomic mass, as we know, it is the mass of an atom of any element as compared to the mass of one atom of carbon atom. So like that, atomic mass means mass of the atom of any element. Similarly, molecular mass means mass of a molecule of any substance. Okay, so mass of a molecule of any substance. So we have to find out here mass of a molecule of any substance, and you know that a molecule is made up of group of atoms. Okay, so as per definition you will be more clear. Molecular mass of any substance is the sum of atomic mass of all the atoms present in a molecule of a substance. So to find out the mass of a molecule of any substance, you have to sum all the atomic masses of the atom present in a molecule that make a molecule. Okay, so molecular mass is also called as relative molecular mass. Why it is called as relative molecular mass? Because as per definition, to find out the molecular mass, we have to sum up all the atomic masses of all the atoms, and you know that the atoms atomic masses are not exact, but they are also called as the relative atomic masses. Whatever the values we have, that is not exact, but the atomic values of atomic masses are not exact, but they are what? The relative atomic masses. Why they are called as relative atomic masses? As we have studied previously, that whatever the values of atomic mass of different atoms we get, it is the average relative mass of its atoms as compared with the atom of carbon 12. So whatever the atomic mass we get, it is the average relative mass. Average, why do we say? Because we take the average of all the isotopes of that element. Okay, so we say that it is the average. And relative, why do we say average relative mass of an atom? Because we are comparing it with an atom of carbon 12 isotope. So to get the mass of a molecule, we have to sum up the relative atomic mass of all the atoms. That is why whatever the molecular mass we get, that is also a relative molecular mass only. That is why molecular mass is also called as relative molecular mass. Okay, now as atomic mass is expressed in unified unit, that is U, or in AMU, molecular mass is also expressed in unit U, that is unified unit, or in AMU, because molecular mass is calculated by summing up all the atomic mass of the atoms, and atomic masses are expressed in U. That is why molecular mass is also expressed in U only, or in AMU. Okay, so we will quickly see the examples, different examples, how to find the mass of a molecule of different substances. Okay, first I have taken the example of water. So if it is asked to find out the molecular mass of water, that means it is asking to find out the mass of one molecule of water. What is it? H2O means what? You have one molecule of water. So molecular mass of water it is asking to find out, means it is asking to find out mass of one molecule of water. Okay, so what and all you have to know for finding out the molecular mass of any substance. First you should know the molecular formula of that substance. So if we have to find out the molecular mass of water, first we should know the molecular formula of water. You know molecular formula of water is what? H2O. That is, it is a molecular formula of water. Now we will write what are the atoms present, type of atoms present in the water molecule. So you know that as per the formula, molecular formula of water, the atoms present are hydrogen and oxygen. Okay, so types of atoms in water are hydrogen and oxygen. So we will quickly write the atomic mass of hydrogen. What is it? It is 1 U or 1 AMU. And we will also find out the atomic mass of oxygen, and it is 16 U or 16 AMU. Why we should write the atomic mass of the atoms present in that molecule? Because as per definition, molecular mass only be calculated by summing up the atomic mass of the atoms present in the molecule of that substance. Okay, so now we know the molecular formula, and we have also found out the atomic mass of hydrogen and oxygen, that is atoms in a molecule, atomic mass of different atoms in a molecule. Now we can calculate the molecular mass of water. So molecular mass of water is equal to, you know, H2O means 2 into atomic mass of hydrogen. Oxygen, how many atoms of oxygen is present in water? 1. So you can just write 1 into atomic mass of oxygen. So you have to sum up the atomic mass of the hydrogen and oxygen, which make a molecule of water. So how will you write? There are 2 atoms of hydrogen and 1 atom of oxygen, which make a molecule of water. So we will sum up both the atomic masses. So there are 2 hydrogen atoms, so 2 into atomic mass of hydrogen plus 1 into atomic mass of oxygen, we will get the molecular formula of water. So 2 into atomic mass of hydrogen is how much? 1 U. So we will write 2 into 1 U plus 1 into atomic mass of oxygen. What is the atomic mass of oxygen? 16 U. So 1 into 16 U. So how much we will get? 2 into 1 is 2 U plus 1 into 16 is 16 U. Now 2 U plus 16 U, how much you will get? 18 U. So molecular mass of water is 18 U. Okay, so like that we can find out the molecular mass of different compounds. Now we will see molecular mass of nitric acid. How to find out the molecular mass of nitric acid, or mass of one molecule of nitric acid. Okay, So for that we should first know the molecular formula of nitric acid. So molecular formula of nitric acid is what? HNO3. That means it contains one atom of hydrogen, then one atom of nitrogen and three atoms of oxygen in it. Okay. So atoms present are hydrogen, nitrogen and oxygen. Okay. So we will first find out what are the atomic mass of the atoms present in HNO3. So atomic mass of hydrogen is 1U, atomic mass of nitrogen is 14U and atomic mass of oxygen is 16U. Now we will sum up all the number of atoms, atomic masses, to find out the nitric acid molecular formula. So we will sum up all the atomic masses of different number of atoms present. Molecular mass of HNO3 nitric acid is equal to, we will write, there is one atom of hydrogen, so we will write 1 into atomic mass of hydrogen plus there is one nitrogen atom, so 1 into atomic mass of nitrogen plus there are 3 atoms of oxygen, so 3 into atomic mass of oxygen. Okay, so 1 into atomic mass of hydrogen is 1U plus 1 into atomic mass of nitrogen. What is atomic mass of nitrogen? 14. So 14U plus 3 into atomic mass of oxygen. So 3 into, what is the atomic mass of oxygen? 16U. So 16U. Okay. Well, how much we'll get? 1 into 1U is equal to 1U plus 1 into 14 equal to 14U plus 3 into 16 is equal to how much? 48U. Okay, so sum up all this. 1 plus 14, 1 plus 14 plus 48U. How much we'll get? We'll get 63U. Okay, 48 plus 14, how much? 62 plus 1, 63U. So molecular formula of HNO3 is 63U. So like that you can calculate. One more, we'll see molecular formula of sulfuric acid. So what is the molecular mass of sulfuric acid? So what is the molecular formula of sulfuric acid? H2SO4, means the atoms present in sulfuric acid are hydrogen, sulfur and oxygen. There are 2 hydrogen atoms present in sulfuric acid, 1 oxygen atom and 1 sulfur atom and 4 oxygen atoms. That these all number of atoms make one molecule of sulfuric acid. So we will find out the atomic masses of atoms present in sulfuric acid. Okay, so atomic mass of hydrogen is 1U, atomic mass of sulfur is 32U and atomic mass of oxygen is 16U. Now we will sum up all the atomic masses. So molecular formula of H2SO4 is equal to, we'll write, there are 2 atoms of hydrogen, so 2 into atomic mass of hydrogen plus 1 into atomic mass of sulfur plus 4 into atomic mass of oxygen. Atomic mass of oxygen means 4 into atomic mass of oxygen means mass of 1 oxygen. So we will multiply by 4, means we will get mass of 4 atoms of oxygen, like that. So we have written like that. So 2 into, what is the atomic mass of hydrogen? 1U plus 1 into atomic mass of sulfur is how much? 32U. So 32U plus 4 into atomic mass of oxygen. Okay, what is the atomic mass of oxygen? 16U. 16U. Okay, so how much we will get? 2 into 1, we'll get 2u plus 1 into 32, we'll get 32u plus 4 into 16. How much we will get? 64u. Okay. So we will sum up how much we will get. 64 plus 32, 96 and 2, 98. 98u is the molecular formula of H2SO4, or we can say the molecular mass of H2SO4, or we can say that mass of one molecule of H2SO4 is 98u. So like that you can calculate the molecular mass of different substances. It can be asked in different ways. Like it can be asked to find out the mass of one molecule of hydrogen. So what you are getting, what you have to find out? Mass of one molecule of hydrogen. So asking mass of one molecule of hydrogen, how it can be written? Formula H2. This is one molecule of hydrogen. Okay. So one molecule of hydrogen contains 2 hydrogen atoms. So you have to find out the mass of one molecule of hydrogen. So how will you write? Mass of one molecule of H2 is equal to how much? 2 into atomic mass of hydrogen. Simply, okay. So 2 into what is atomic mass of hydrogen? You know it is 1u. So it is equal to 2u. So mass of one molecule of H2 is 2u. Okay, very simple. Now try to understand the question also. Find out the mass of one molecule of chlorine. So one molecule of chlorine means it is in the form of this. This is one molecule of chlorine. This is one molecule of chlorine. So we will not write 1 here. It is just showing it is one molecule of chlorine. So one molecule of chlorine is made up of 2 chlorine atoms. है ना? So you can calculate like that only. Mass of one chlorine molecule or one molecule of chlorine is equal to, there are 2 atoms of chlorine present in one molecule of chlorine. So you can write 2 into atomic mass of chlorine. Now atomic mass of chlorine is 35.5 mu. This is also 35.5 mu. Okay. Atomic mass of chlorine means mass of one atom of chlorine. You know, na? So 2 into atomic mass of chlorine is how much? 35.5 u. Okay. Which is equal to how much? 17.1 u. So the mass of one molecule of chlorine is 71 u. This is the answer. So like that it can be asked, find out the mass of one molecule of nitrogen, find out the mass of one molecule of oxygen. So you have to calculate like that only. Okay. Now earlier we have just studied to find out the molecular mass of water. So the question can be twisted and can be given as find out the mass of one molecule of oxygen. So don't be confused. If it is asking to find out the mass of one molecule of water, means it is asking just the molecular mass of water. So how you have calculated the molecular mass of water, like that you have to calculate one molecule of water. So how will you denote one molecule of water? One molecule of water formula is H2O. This is one molecule of water. Okay? So one molecule of water contains 2 hydrogen atoms and 1 oxygen atom. Okay. So what are the atomic mass? Oxygen atomic mass is what? It is 16u, and both the hydrogen contains 1u and 1u. These are the atomic mass of hydrogen. Okay, so we can just write mass of one molecule of H2O water is equal to 2 into atomic mass of hydrogen, atomic mass of hydrogen plus 1 into, it contains 1, so 1 into atomic mass of oxygen. Okay, so 2 into, what is the atomic mass of hydrogen? 1U plus 1 into atomic mass of oxygen is 16U. So how much you get? 2 into 1, 2U plus 1 into 16, 16U, 16 plus 2, 18U. Same you are getting now. So the mass of one molecule of water is 18U. So mass of one molecule of water or molecular mass of water, both are same. We will get 18U only. So like that question can be asked. You should be very careful when you are reading the question, and don't confuse if it is asked in this way. Okay. So you have one more topic, that is formula unit mass. Formula unit mass is same as molecular mass, just formula unit mass we use to calculate the mass of one molecule of ionic compound. We use formula unit mass, we use this word for the ionic compound. Okay, and molecular mass we use for the general compounds. Okay, for specifically for ionic compound we use formula unit mass word. So we will see what is the definition of formula unit mass. Formula unit mass is of a substance is the sum of atomic mass of all the atoms as that of molecular mass. Definition is same. The sum of atomic mass of all the atoms in a formula unit of an ionic compound. Okay, in a formula unit means in a molecule of an ionic compound. There we studied sum of atomic mass of all the atoms in a molecule of a compound or a substance. Here in molecular unit mass, it is the sum of atomic mass of all the atoms in the formula unit of an ionic compound. Formula unit word is used for the substances whose constituents are ions. So this is formula unit is used instead of the word molecule for the ionic compounds. We use that. Example, sodium chloride. You know sodium chloride is made up of sodium ion and chlorine ion. Formula if we see, it is NaCl. So the formula unit is NaCl and its constituents are sodium ion and chlorine ion. So because this formula is NaCl whose constituent are Na plus and Cl minus, so instead of calculating molecular mass, we will say we will calculate the formula unit mass. Okay, but the calculation will be same as that of the molecular mass. In the same way we will calculate. So we will see what are the ions present here, sodium ion and chlorine ion. So as per definition, we have to sum the atomic masses of all the atoms in the formula mass. What are the atoms in the formula mass? Sodium and chlorine. Okay, so you can just write here atoms present. You can just write atom presents are sodium and chlorine. So what atomic mass of sodium is 23U and atomic mass of chlorine is 35.5U. So just like that we will, instead of molecular mass, we will write the word formula unit mass of sodium chloride is equal to, there is one sodium atom, so 1 into atomic mass of sodium plus 1 into atomic mass of chlorine, and we will calculate. 1 into atomic mass of sodium is 23.23U. So 23U plus 1 into atomic mass of chlorine. What is the atomic mass of chlorine? 35.5U. So 35.5 Now we will calculate 23U plus 35.5U. 125.5, 35.5. So overall we will get 58.5U. So formula unit of sodium chloride is 58.5U. It is nothing but the molecular formula only, but when you are calculating the mass of an ionic compound, mass of one molecule of ionic compound, then instead of using the molecular mass, you should use the formula unit mass word. Okay, so that was about your molecular formula and formula unit mass. So in formula unit mass, you could have different ionic compounds like potassium chloride, ammonium chloride. Okay, like that you can calculate the formula unit mass of those ionic compounds. Okay, now we will see the solved questions. The first one is write down the formula of the following compounds. Okay, so first was aluminum sulfate. So students were writing the valency. As I told you, in the case of ionic compound, the number of net charge present on the ion is only its valency. Okay, so if aluminum is in the form of Al plus 3, it means there are plus 3 net charges on aluminum. So automatically the valency will be the number. How much it is? 3. So 3 will be the valence. Similarly in SO4, sulfate can be written as SO4 2 minus. So overall charge on sulfate SO4 is 2 minus. So automatically the number will be its valency, 2 minus, number of the net charges. So 2 will be the valency of sulfur. So in this way only you have to write all the ionic formula, ionic compound formula. Okay, so valency, you know, aluminum will be 3 and sulfate, as we have predicted from its ion, it is 2. So when you cross multiply it, you will get Al2 and SO4 3. So in SO4, writing SO4, you have to give bracket and write 3, so that this 3 belongs to the whole symbol, the group of atoms. Okay, similarly second is sodium oxide. So here I am showing you the charges also, so that from there you can predict around the valency of those atoms. Okay, so Na plus means 1 is there, so 1 is the valency of sodium. O2 minus means 2 is the valency of oxygen. Cross over each other, the cross over will get Na2O1, which can be just written as O. So this is the formula for sodium oxide. Similarly, you have aluminum chloride. The net charge on aluminum is Al3 plus, you know, and chlorine is in the form of Cl minus. So Al3 plus means valency will be 3 and chlorine minus means the valency will be 1. So when you cross multiply it, you will get Al1 and Cl3. So this will be the valence formula of aluminum chloride. Similarly, you have sodium sulfide. Now sodium can be written as Na plus, sodium ion, and sulfide ion can be written as S minus, or you can write S2 minus. Okay, so plus means Na will be in the form of 1 valency of sodium will be 1, and sulfide has 2 minus charges, so valency of sulfide will be 2. Now cross over this, you will get Na2S1, which can be just written as S. This is the formula of sodium sulfide. Now magnesium hydroxide, Mg plus 2, and hydroxide will be written as OH minus. So plus 2, so magnesium valency is 2. OH minus, so hydroxide valency is minus. Minus means minus 1. So it is 1 here. So Mg1, which we will just ignore 1, and OH2. So while writing OH2, we have to put bracket. Don't forget to put bracket over the symbol who has group of atom in it. Okay, And also while writing valency, most of you have written +2, -1 like that. So this is wrong. When you are writing the valency, you should just put the number, not the charges. If you put charges, it will go wrong. So whenever you are writing valency, don't put charge before the number. Okay. Now second question is, write down the names of the compound represented by the following formula. Okay, so we'll just write the names. Al2SO4 whole 3. Al means aluminium and SO4 represent the sulfate. So we'll just write it is aluminium sulfate. Similarly, here it is calcium, and this is here is chloride. So when you are writing, the chlorine becomes chloride. So calcium chloride. Then here potassium and SO4, you know, it is sulfate. It is called sulfate. So potassium sulfate. Similarly, this is K means potassium, and NO3 represents what? NO3 represents nitrate. So potassium nitrate. Okay. And Ca represents calcium, and CO3 represents the carbonate. So it is calcium carbonate. So if you read the table, whatever I have given you, the table which consisted of ions, then its symbols, valency, etc., then you are able to solve all the questions. If you are not clear with all those things, it will be very difficult for you to predict the formula or the name of the compound. Now third is, what is meant by the term chemical formula? So chemical formula is the representation of composition of compound through chemical symbols and numerical subscript. Example H2. Here we have written the symbols of the composition, and the number of atoms we have shown by the numerical subscript. So the representation of composition of compound through the chemical symbols and numerical subscripts. Okay. Now find out the empirical formula of ethanoic acid. So molecular formula of ethanoic acid was given to you in the question, which was C2H4O2. Now you know the empirical formula is nothing but the most reduced form or most simplest ratio of their atoms of any compound or a molecule. So C2H4O2 means carbon, hydrogen, oxygen are in the ratio of 2:4:2. So we will just simplify it. We will make it in most reduced ratio or most simplest ratio. How can we just get in a most reduced or most simplest ratio? If we take common 2, then we will get 1, 2 and 1. 2 common means 2 1 are 2, 2 2 are 4 and 2 1 are 2. So carbon in the ratio of 1, hydrogen in the ratio of 2 and oxygen in the ratio of 1. So carbon 1, hydrogen 2 and oxygen 1. So we cannot simplify it anymore. So this is only the simplest form of the simplest ratio of their atoms of ethanoic acid. So it can be just written as, by ignoring 1, CH2O. So this is the empirical formula of ethanoic acid. Okay. Now next question was, give the names of the element present in ammonium chloride. So first we'll write the formula. We can predict the formula. Ammonium, you know, it is written as NH4 and it contains the net charge NH4 plus, and chloride can be written as Cl minus. So what will be there? Its valency. Plus means it will have valency 1, and chlorine is minus, it will have valency 1. So cross over this, you will get NH4 1 and Cl 1. Ignoring 1, we will write NH4Cl. So this is the formula of ammonium chloride. So what are the elements present in ammonium chloride? Nitrogen, hydrogen and chlorine. These three elements are present in the ammonium chloride, which was asked in the question. So elements are nitrogen, hydrogen and chlorine, and the formula is NH4Cl. Okay, you have to write like that. Now what is the valency of nitrogen in ammonia? Okay, so ammonia formula, if you know, it is NH3. So just NH3 means, how you have predicted? you write N here, H here, N1, H3, you have got N1. So by crossing over, you have got N1, and H3 you have got. So by crossing over, you would have got NH3. Okay, N1, H3. You got NH3. Now it is asking what is the valency of nitrogen. You just see below what is written, 3. So the valency of nitrogen is 3. Okay, well, how will you do? Just do NH3. If you know, just write N and H. You have got 1, which means by crossing over you have got 1. So by crossing over you write 1 here, and by crossing over you have got 3. So write crossing over as 3 here. When you see the valency, nitrogen will get the valency 3 and hydrogen 1, you know. So automatically you can just write, by seeing this only, the valency of nitrogen will be 3. Okay. Now what is the valency of CuCl2? Actually, intentionally I gave you CuCl2. This is actually CuCl, copper chloride. But if I have given you CuCl2 and I have told you to find out the valency, first do as per the method. So write CuCl and write its valency. Cl, or you know, it is always 1. The valency is always 1. Cu can have valency 1 or 2. You are not sure of that. Okay. But if you write, let's say if you write 2 here and do crossover, then what formula you will get? Cu1, and you will get CuCl2. Cu1 Cl2. So you are getting overall CuCl2. But I asked you to find out the valency of copper in Cu2Cl2. The formula whatever we have got, it is Cu1Cl2. So the valency whatever I have put for copper is wrong. So if I'll now do it with copper valency 1 here. Earlier I did with 2, but the formula whatever we got, it is not Cu2Cl2. So I have put the valency of Cu as 1, and now I am crossing over this. So again I will get Cu1 and Cu1 and Cl1. Okay. So here I am getting Cu1 and Cl2. If you multiply both the atoms by 2, you will get Cu2Cl2. Okay, or if you simplify it, you will get Cu1Cl1. That means whatever the formula you have got, CuCl2, it is similar to Cu1 and Cl2. Now we will write the formula we have got is correct. Now we will see what is the valency of copper by doing this. So copper valency we have got is 1. So here the valency of copper is 1 here. So this is the right answer. Most of you have written 2 also. Just correct it. How you have done, just follow this method only, and you can just solve the answers. Thank you.